Right. So if you look at page 5, we have operations, right? So you can multiply, add, and subtract the functions. So when we go backwards, they give you the result. You try to find the two functions that can add together, right, or subtract to make the new function. Okay, so same with composite. Composite is also made up by more than one function. So it's like we have f of k, which is the answer that we got down here. So now going backwards means they will give you the result here. And you need to find two functions that can make up the final function, okay? So we can go over one together, okay? So similar, there are different ways depending on how you think of it. So there's no single answer for this. And here you have two functions here. Write the function h of x as a composition of two functions. One is f, one is the g. Okay, so you need to make sure you identify which one is the inside, which one is the outside, right? Composite function means you have inside and outside functions. So we want one, here we'll try one, okay? Try one together. So the function that goes inside, you can, for example, can choose, okay, I want this one, x plus 1, to be the inside. Okay, so the inside function will become the x, right? So it will be, so the outside function will be whatever that's outside the circle, okay? The circle will become the x. So for example, I will say the inside, let's call this g of x. Then I will say g of x is x plus 1, right? And I'm going to take this function into the inside the square root. Then I will say f of x is 8 root of x minus 3, right? So this part can go into this circle, right? Then it will make the original function. But then at the end, you need to specify what kind of composite, which one is the inside one, which one is the outside one. So you have to make sure you also write this part out. H of x, right on the side, right at the bottom, okay? So from here, we would have g of x inside the f, right? So I'll write it as f of g of x. Okay, so this will be one example of the two functions that can make up the h. Okay, so can anybody come up with a different one, different inside and outside, other than the one I choose? Right, here I chose x plus 1 to be inside. Any other choice? There are many ways.
Yes.
Okay, William, what do you want to choose to be the inside?
Square root x plus 1.
Okay, so the whole thing, let me write the original one again, okay? So you say you want to include the square root, right?
Yeah.
Okay, so let me write that down. So this whole thing will be the inside. So inside we'll use it as g of x. Okay, so what will be the outside then?
8 and then x minus 3.
That's good. Very good. Okay, so you can double check, see if you replace this into the x, right? Does it get the original h of x back? Right? If it works, then that also works. Okay. So again, we'll have h is f of g of x. Because it will be different if it's G of F, if you swap the order. Make sense? Okay, so there are many ways. So I would like you to try B, C, D right now, okay? So you just need to find one of the way and then we'll check, okay? If you got something different, you can share as well. We'll check if your answer is correct as well, okay? So once you finish the three, please raise your hand and then we'll go over it. And let's keep it consistent. So we'll use G as the inside and F as the outside, okay? If anyone wants to check just question B, you can let me know. Okay, you can tell me your answer. We can see if it's right before you move on to other ones. If you're confident, then just finish all three.
I am confident I'm all wrong.
Okay, you're confident all wrong. All right. Okay, let's see your answer, William. Okay, just for B. What's your G?
My G is x minus 5.
Okay, that's it? Just X minus 5.
Yeah.
Okay, and F of X?
3x squared plus 2x.
Okay. And then we have H is G F of G, right?
Yes.
Okay. Anyone got something different? If you have something different, you can check, okay? You can see if it works or if there's any mistakes, okay? Please raise your hand if you finished all three questions. So William's answer is okay, right? That one is good. If you have something different, let me know. Okay, Tiana, what's your choice for C?
For g of x, I have x plus 2,
Mm-hmm.
And then for f of x, I have 3 over x to the power of 3.
Okay. Thank you. Yeah, that looks good. So H is f of g. Anyone has different for C? Everyone think the same way? Okay, Trudy, which question are you working on?
I finished
You finished?
D.
Okay. You finished D? All right. Remember to raise your hand if you finished. Samantha, how about you? Which one are you working on?
C.
On C, okay. Vicky, are you done? Question D?
I'm still working on it.
Okay. Let me know when you have an answer. Okay, Vicky, what do you have?
For g of x, I just wrote x.
Okay.
And for f of x, square root of x plus 3.
Okay, if you choose like that, then every question can do like this, right? Don't you
Yeah.
think? Yeah, okay. So usually we won't use this way. Just like I remember last time William said anything times one, right? So you can have one function is one and then the other function is the original. So do you have other choice, right? Let's think of other way. Otherwise, every question you can say one function is x. It's not wrong, okay? Just that I don't think they will want you to do that. It doesn't show, okay? Catherine, how are you doing? Which question are you working on?
I don't really know how to do it.
Do you understand question A?
No.
Okay, do you know what this question is about? Catherine.
Not really.
Okay, this question is trying to go backwards, okay? We want to find two functions, so then one function sub into the other one can get the question back. Okay, so like question A, here we chose inside to be x plus 1. Okay, Catherine?
Okay.
Yeah, okay, inside is x plus 1. So if I replace the x plus 1 into the square root, then it will look like the original function at the top, at the question. Right, make sense?
Yep.
Okay, so that's why so once you decided which part to be the inside, then the inside part will become the x, because it's gonna act as a box. Okay, so if you look at the other example, okay, so what's the inside function, Catherine?
X minus 5.
Yeah, okay, so all the x minus 5, this x minus 5, this x minus 5, both of them will become x. So your outside function will be 3x squared plus 2x. Make sense now?
Yep.
Okay, so you just choose whatever you wanted to be the inside. So for example, D, what do you want to choose to be the inside?
X.
Okay, X, Vicky already chose that, right? Because if I use X as the inside, and then we're gonna replace with X, will look the same as before. So we want to do something so it's different, okay? Can you think of a different choice? Other than just X, okay? We won't use just X. What do you want to use?
I don't know.
Not sure. Vicky, what do you think? Do you have some other choice you want to do?
I don't know either.
Okay, Trudy?
I just also used X.
Say that again?
I also used X.
No, you also use X. Okay. William, did you also use X?
Oh, what? Hello?
Yeah. What did you use for the inside?
I use square root of x.
So the whole square root as the inside.
Uh-huh, uh-huh.
Yeah, better than X, right? Then what will be the outside function, Vicky?
X plus 3.
Yeah, so this way it actually shows you have a function sub into the other function, okay? So you can choose different ones, okay? There's usually more than one ways, right? But every single question, the inside function is X if you don't do anything, right? So for example, like C, okay, what will be another choice to be the inside? Let's try one more, okay? Catherine, what do you want to choose to be the inside?
X plus 2.
We already did that, right? X plus 2 is right here, right? And then the outside will be 3 over x cubed. I want a different choice.
I don't know.
Not sure? Vicky? How about you, Vicky? What do you think? What's a different choice for this one?
X plus 2 cubed.
Okay, sure. Okay, we can do x plus 2 cubed. Then whatever you see on the inside, you circled it, that part is going to become x, right? So what will be the outside function, Samantha? Yeah, 3 over x. Okay, so both of them are correct answer. Okay, both of them has g inside the f. Okay, so if you are doing the homework, right, going backwards, I will need, there's no single answer here. I need to check each one of your choice, see if it works. Okay, so this one you could do it this way too. Okay, any questions? Okay, so that's it for all the composite function. So you need to know how to go back forward and know how to go backwards as well. Okay. So now the new concept for today that we're going to cover is called the inverse function. Okay, so which is starting on the next page, page 8. Okay, so if you already printed out, okay, you can turn to page 8. Otherwise, you write it in your notes. So different from composite function. Composite function, let's quickly recap, right? Remember we said composite function is like you take the ingredient, put it into the factory, and then get a component, and then use the component, put it into the second factory, and make a product, right? It's like relay, okay? One goes to the next one, go to the next one. So the composite function. Now, inverse function does different things. So for example, if I have some ingredients, right? So let's say you have some nails, right? Screwdrivers, right? And little elements, right? So let's say we have 2, 3, 4, right? Those are the names, okay, of the little elements. And then I put it into the factory and then I start building, right? The 3 can 4, right? All of them can produce a new things after it insert into a function, into a factory. So let's say 2 will become 7, right? And then 3 becomes 8, and the next one becomes a 9. So what do you think the function is? How do I go from x here become the y there? Donna? What's the f of x that will work?
Um,
What should we do to make all the input become all the output there? Is there a pattern?
yeah.
Yeah, okay. So what function should we write so it works?
I don't know yet.
Don't know yet? What about Cindy?
X plus 5.
X plus 5. Donna, do you agree? Does x plus 5 work?
Yeah.
Right? You look at the pattern. Each time you take the x, add the 5, right? Take the x, add the 5. Take the x, add the 5, right? So the function is adding 5 to all the input. So that's going forward. Now, if I want to go back, look at the red. Then going back, breaking down the original product back into its element, right? So it's like you build something and then you break it apart, going back. So that will be called the inverse function. So we use little symbol with a little -1 on the top. This is called the inverse function. It brings the y value back into the x. So that means we pretend all the y are the x now. Okay, all the old x are the y now for the inverse. So we treat the y as x. So what will be the new function, the inverse one? Tiana, what do you think?
X minus y.
Okay, so I have to do the opposite, right? X minus 5. So for example, I try 7, right? 7 subtract 5 will give you 2, right? And so on. 8 subtract 5, 9 subtract 5. Very good, okay? So this is the concept of inverse. So going forward and then coming backwards. The backwards one is called the inverse. So it's different from the composite. Composite is keep on moving forward, right? You get one output and then use the output put into another function, right? A different one. So this one is only one function. And then you just use that, try to go forward, go backwards, okay? So now if you understand this, we'll look at the definition, okay? So given y equal f of x, so you see you only need to know one function, right? If x and y values are switched, okay, you can underline that. So that means 2, here's x, but later it will become the y, right? 7 used to be y, inverse, it will become the x, right? X and y are switched. Then the new function is called the inverse function. So inverse function is this one, okay? And the notation, you have already seen it, right? With a -1. So this little -1, okay, make sure you make a note on the side. F inverse of x, okay, this is how we say it, is not the same as f of x with a -1, okay? That little -1 is not exponent, okay? This is exponent, okay? But this -1 here is called the inverse. It's not exponent, different meaning, okay? So even though they're both at the top, right? Top corner, but they mean different thing. If you want to show x exponent, you have to put it on the outside, okay, at the back. And then here it's about the graph, okay? Don't worry about this part. It says the graph of those two will reflect over y equal x line, okay? You'll see that later, okay? So let's look at an example now. The one on the top here is sort of example, but it's not really the function, right? They don't give you the function. So let me give you a function and we'll do this one together. So find the inverse, right? This is our goal. Find the inverse of the function f of x equal to x plus 1. So this is the original, right? It takes one value and then move it to the other one. And then we're gonna graph both of them, okay? And then see how they will reflect to each other. So let's start with graphing the original one, okay? We'll use some negative numbers as inputs, right? So f of x is this one. Okay, I'll copy one more time. Okay, so we'll choose -2, -1, 0, 1, 2, just like the points we use for problem. Okay, some negative number, some positive number. And then for the original function, I'm gonna graph with the blue one. Okay, later we'll use red. Okay, for the inverse. All right, so if you get the points for the y, please raise your hand. So you just take all the x, put it into the f of x, okay? Anyone here has no idea what's going on? Let me know. We can go over the whole thing again. So right now, please find the y values for each x. If you don't know how to do that, let me know. Please raise your hand. Don't forget to raise your hand if you're finished. Catherine, Ray, are you done? Okay, Ray, can you tell me your y values?
I don't know if it's correct, but -3, 0, 1, 3, 5.
Okay, how about you, Catherine? Catherine, do you have different ones?
I got -3, -1, 1, 3, and then 5.
Okay, so the one with the 1 is different, right? Let's check, okay? Trudy, how about you?
Wait, it is one. It is -1. I made a
Should be
mistake.
-1?
Yeah, we got the same thing, but with -1.
Okay, thank you. Okay, very good. So this is teamwork, right? Okay, so anyone has trouble with the points? Should be pretty straightforward, right? You just plug it in. Now let's graph the point and then make a line. This is a linear graph. So let's go to -2, -3. I'm gonna use blue color, okay? So if you have different color, you can use it. -1, -1, 0, 1, 1, 3, 2, 5. Okay, so it should line up. If it doesn't, right, something's wrong. So we have this line. Okay, so please label it. This one is f of x, original. Okay, so remember from the introduction, we said that the output for the inverse, for the original, it will become the input for the inverse, right? So used to be x will now become the y. Used to be the y will now become the x because we're trying to go backwards, okay? For original, it's going this way. For inverse, it's trying to go back, right, for the red. So all the y value will now become the x. So that's pretty easy. And you just copy over. Right, and then for the y values, they are going to be the x value before, right? So it'll be -2, -1, 0, 1, 2. Make sense? Right? You just use the original table, then you can get the new graph. So same thing, we're gonna plot the new one. Okay, so -3, -2 will be here. -1, -1 will be the same place, right? 1, 0, 1, 0 will be here. And then 3, 1, 5, 2, 5, 2. Okay, and then connect. So this one, the red one is the inverse. Any questions so far? We all got a graph? Okay, so this graph, the inverse graph, has a special property here. It has a reflection, right, over here. We look at the top property f of x and f inverse. They will reflect the line y equal x. Y equal x means the points, the line must go through the points 1, 1, 2, 2, 3, 3, 4, 4, right? X and y are the same. Y equals to x. We go to here, 1, 1, 2, 2, 3, 3, 4, 4. Same thing with the other side. So you see this line, it goes right in the middle between the two. Okay, so this line is kind of off here. Okay, so this line is y equals to x. So this is called the reflection line. For all the inverse, they always reflect over there because this is right in between, right? Between where they swap. Okay, if you swap y equal x, switch x and y, it still look the same, right? So that's the line that never change. Any questions so far? Okay, so this is the graphing part. Now the harder part is trying to get a function. Okay, remember over here, the example at the beginning, we said that if I want to go back, I have to do the opposite, right? It used to be adding 5, I have to do subtract 5. So same thing with this one. Just think about how we get forward, right? The input needs to times it by 2 and then plus 1. What do you think will be the opposite step, trying to go backwards? Times 2 and then plus 1. So if I want to go back, what should we do? Anybody?
Is it divide 2 minus 1?
So divide by 2, let's see. I write it down first, okay? See if it works, okay? Let's erase this. So you said divide by 2 and minus 1, right?
Yeah.
Okay, so let's see if it works. Okay, let's try. So we're gonna try with the red, right? Because it's supposed to be inverse. So if I take negative 3, put it in, negative 3 divided by 2, what's that? Eric?
It's 3 over 2, 1.5.
Decimal? Negative
Yeah.
1.5, right? Negative 1.5 and then subtract 1.
Negative 2.5.
Negative 2.5, but we want to get what?
Negative 2.
Negative 2, right? So right now it doesn't work. Okay, any other idea? Good try, okay? Good try. Times it by 2 plus 1. What will be the opposite? Anyone else wants to try? Or you can try again, right?
X minus 1 divided by 2.
So x minus 1 all over 2 like this.
Yeah.
Okay, let's try it out. So let's say we use negative 3 again. Negative 3 subtract 1, what is that? You right?
I don't know.
Negative 3 subtract 1. Negative,
2. No, negative 4.
yes, okay. And then negative 4 divided by 2.
Negative 2.
Negative 2, it works, right? Let's try another one, okay? Let's say we use the last pair. We'll put 5 in, okay? Cindy, can you help us? 5, plug it in.
Wait, what?
Are you lost?
Wait, I missed the question. Sorry.
Okay, I want to try 5. Okay, and then we'll put 5 into the x up here. So what do you get?
Wait, plug 5 into x for
Yeah,
f.
right here, this x. You see it?
No,
Huh?
no.
Okay, where are you lost?
No, I'm confused. Like, what am I solving for?
Okay, we are not solving anything. We're just checking if erase answer works or not. Did you get the part where she said x minus 1 divided by 2?
Yeah.
Okay, so I'm saying we're checking if this answer is right. So we take the x value and plug into there.
Oh,
Okay, so we're checking 5. If x is 5,
yeah.
okay, and plug it in, what do you get?
2.
Hmm?
2.
Okay, how do you get the 2? Can you explain the steps?
5 minus 1 equals 4 divided by 2.
Yeah, okay, 4 divided by 2 is 2, right? So it works. So it looks like it will work, okay? So think about the original function, right? How she got it right. Times 2 plus 1, right? Times 2 plus 1. If I want to go back, I have to go back in the backward order. So I have to subtract 1 and then divide by 2, right? Instead of divide by 2 and subtract 1, you have to go back in order, okay? So that will be the idea here, okay? However, it's still kind of difficult if we try to do it like that, okay? Here, let me erase, okay? So here we want to go over the steps, okay, but I will keep her answer on the side, okay? Later we'll compare. So step 1 is to write f of x as y. Okay, what that means is right now the function, right, the question they give you, it doesn't have y, right? So I will replace the f of x with y. So write y equal 2x plus 1. So this is step 1. Step 2, to get the inverse. Inverse means x and y, they must switch around, right? So step 2 is switch x and y. Okay, so I will swap those two letters. So x equals to 2y plus 1. So the moment that you switch, this is called the inverse. Okay, it's already called the inverse. You already found it, you're done. Okay, however, writing it like this is not really useful, right? Because usually we like to find the y value, right? Usually the y should be by itself. So we need to isolate y. Okay, so step 3 will be called isolate y. Okay, so you'll see that as we isolate y, what will be the first thing to do? Cindy, how do we isolate y?
Move it to the other side.
Which one needs to move over first?
1.
Yes, okay, and if I move it over, it will become,
X minus 1.
yes, so that's why we need to do minus 1 first, right? Instead of divide by 2 first. So after you move the 1 over, and then you need to divide both sides by 2 to get x minus 1 over 2 is the y. So this is called the inverse. So the moment that you swap them is inverse already, but then you don't want to leave your answer like that. You want to isolate the y. Any question? Okay, so your final function, right? You can write down using the symbol, right? The new symbol that you learned. Inverse function is x minus 1 over 2. So this is our inverse. This one is the original. This is the inverse. Okay, are we clear about everything here? 2 things you need to know, okay? One is you need to know how to get the graphs. Second thing is you need to know how to get the inverse function. Okay, so this part is really important, okay? I would like everybody to turn on your mic or repeat these steps together. Please turn on your mics, everyone. Okay, so let's say it together. Write f of x. Everyone?
Write f of x.
Okay, one more time. Write f of x
Write
f of
f of x
as y.
as y.
Next one, switch x and y.
Switch x and
X
y.
and y.
Isolate y.
Isolate y.
Well, some of you are not speaking, I can tell from the mic. Okay, let's say one more time. F of x as y.
F of x as y.
Okay, Vicky, are you saying? Okay, switch x and y.
Switch x and y.
Isolate y.
Isolate
y.
y.
Okay, graphs reflects. Say again,
Graph
Reflect
over y equal x.
over y equals x.
Okay, very good. Okay, what that means is the green line, right? The inverse and the original, it will reflect over the green line. The green line is y equal x. Okay, good job. So let's try this one, okay? So I think we will take a break first. We'll take an early break. After you guys come back, we'll do question 9. Okay, so 15 minutes. So I'll see you at 2:40. Okay, and if you have questions about any of the things we covered right now, you can stay after, right? You can ask me. Otherwise, I'll see you in 15 minutes.